Systems of linear equations are very applicable. They show up all over the place because there's lots of restrictions placed in our world that aren't specific equalities, but rather inequalities. So here, a factory produces two agricultural pesticides, A and B. For every barrel of pesticide A, the factory emits 0.25 kilograms of carbon monoxide and 0.60 kilograms of sulfur dioxide. For every barrel of pesticide B, it emits 0.5 kilograms of carbon monoxide and 0.20 kilograms of sulfur dioxide. Pollution laws restrict the factory's output of carbon monoxide to a maximum of 75 kilograms per day and its output of sulfur dioxide to a maximum of 90 kilograms per day. So there's a couple things going on here. Okay, we've got these two pesticides, and each emits a certain amount of each of these pollutants, and there's this restriction on how many pollutants they can emit. And so what we can do is find a system of inequalities that describes this. So we're going to start by just assigning some variables. So the two unknowns that we have are the number of barrels of these two pesticides, A and B. So I'm going to call those X and Y. We're going to call X the number of barrels of pesticide A, and Y will be the number of barrels of pesticide B. So first of all, I like to start with the information that's just stated. Okay, we know that the factory emits 0.25 kilograms of carbon monoxide and 0.6 kilograms of sulfur dioxide. Okay, and then barrel B does different values of those two things. So what we're going to do is we're going to have actually an inequality for carbon monoxide and an inequality for sulfur dioxide. Okay, so carbon monoxide. We can get the amount of carbon monoxide emitted by taking 0.25 and multiplying that by X, okay, the number of barrels of A, pesticide A, and then adding from B, we get 0.50 kilograms per barrel, so times Y. Okay, that's the carbon monoxide. And we know that the total emissions of carbon monoxide need to be less than or equal to 75. Less than or equal to 75. We do the same thing for sulfur dioxide. Okay, from pesticide A, we have 0.60. So that's times X. And then plus for pesticide B, we have 0.20 kilograms. So that times Y. And the total amount of sulfur dioxide that can be emitted has to be less than or equal to 90. So these are the two restrictions that are placed. There's a restriction on carbon monoxide and a restriction on sulfur dioxide. Hidden in this problem, however, are two more inequalities. And those two inequalities are just the fact that we're working with real physical quantities. Okay, the number of barrels that we produce for both of these, okay, has to be greater than or equal to 0. Okay, it doesn't make sense to produce a negative number of barrels. So this here then is the system of inequalities that represents this problem. These are pretty involved. So as far as graphing it, I'm just going to go ahead and look at my computer-generated graph of this. These, of course, are just lines, so it wouldn't be too difficult to go through and find all of those lines and the points of intersection. So here is the feasible region that we have. Now, would it be legal for the factory to produce 100 barrels of pesticide A and 80 barrels of pesticide B per day? So this is saying, is it okay if X is equal to 100 and Y is equal to 80? So we just go here and we see, well, here's X equals 100 and Y equals 80, and it's right around there. Okay, and that looks good. So yes, okay, that would be legal. For part C, would it be legal for the factory to produce 60 barrels of pesticide A and 160 barrels of pesticide B per day. Well, that's when X is equal to 60 and Y is equal to 160. That would be right here and all the way up to this point right here. And that's outside of the feasible region. So no, this would not be legal.